changes, everyday things. Been through it all, movies, cheap wine, clubs and cloud nine. All of this time, I'm still longing for your love. You woke me up in the middle of the night. I knew that something wasn't right by the look in your eyes. So close but still so far away. You said we had a good run, but you're turning the page. I wanna try it one more time, like we're separate ways. Too close to let.
Hey. Hello, hello. So welcome back to Van Gogh Room. So today we are having the next session called From Monking to Rocking Your Test with Test Containers. And honestly, I'm quite excited because I don't know what test containers are, but I am excited that we're learning from the best because with us today is Barend Linders, and he works for Nicolab, which is a company that deals a lot with, with medical use cases. They're working on strokes care. So that makes me think they know a thing or two how to be reliable and efficient. So give a round of applause to Barend.
Thank you very much. Hi, I'm Barend, and I'll tell you something about test containers. I'm a little bit nervous, but also quite proud to be on the stage. I've been going to PyData since, I think, 2017, when Spark was the cool kid on the block. So it's very nice to now be on this side and give back a little bit to the community. It'll be quite a light talk. Maybe everybody is a bit tired of causal inference or people that develop Rust packages that will replace pandas. I can't remember the name, stuff like that. This will be easily digestible. So let's dive into it. I've tried to deduce some questions you might still have. For example, who is talking to you? What does Nicolab do? We already had a little intro. And what problem did we run into? Hopefully you can, to a degree, relate. Then I'll show you what test containers actually are. Can you show us a little demo? Spoiler alert, yes. And then how do we actually use them, and did we solve the problems that I stated at the beginning? And then we'll wrap up with some advantages and disadvantages and a conclusion. So, who am I? I'm a hydrogeologist turned data dude. Currently I work as a data/software engineer at Nicolab. I love riding my mountain bike in my free time or play padel. If you want to talk about any of these things, come and talk to me afterwards. Okay, so what does Nicolab do? We streamline the emergency workflows by connecting physicians with AI-analyzed patient scans, and we do this mainly in stroke care. Okay, that's a bit of a mouthful, but if there's emergency care, especially in the stroke space, we'd like to optimize the workflow that physicians and patients face. Okay, cool. What is a stroke? I think everybody has heard it, but do you really realize what it is? There are two types. We've got the ischemic stroke, when there is, like, for example, a little blood clot blocking flow to the brain, so your brain doesn't get oxygen. Or you can have a hemorrhagic stroke, where there is a rupture of a vessel, and then that also obstructs healthy blood flow to the brain. Both are problematic in their own way. So that's at a very high level what a stroke is. And obviously, if your brain isn't getting the oxygen it needs, we need to treat the patient very quickly, right? Because the brain is slowly dying. Okay, is that important? Yes, it is. Because 1 in 4 of us will have a stroke in our lifetime. That's crazy, right? 1 in 4, 25%. For example, in the US, every 40 seconds, somebody might have a stroke. And if you have a stroke on average, every minute that you have one will cost you about 2 million brain cells. So the quicker we can salvage the stroke, the higher quality of life somebody will have. That's nice, right? Okay, so what does this workflow look like in practice? Okay, somebody has stroke symptoms, they go to the hospital, might be a regional one, a small scale one somewhere. And then the first thing the people in the hospital do is they'll put you in a CT scanner. It often happens in these smaller scale hospitals that, or if people arrive in after hours, that the real expert is not in the building, in the hospital, and then inexperienced staff might miss already 20% of these cases. Then there's the communication overhead, so people might call the expert who's at home, but they might not have proper access to the scans, so there's inefficiency there as well. And then if a patient comes into this local small-scale hospital and they need to be treated by an expert, for example at the AMC here in Amsterdam, they get sent there, and then at the AMC they might get rescanned again because the scans don't transfer properly between the hospitals. So there are some inefficiencies here that we'd like to solve. Okay, how do we do that? We have a stroke viewer product. The patient still has a stroke. Unfortunately, we cannot solve that part. That would be really nice. Scan still happens, and the scan gets uploaded to our system, and we do a suite of algorithms that we run on it. So we do some analysis, and we push them back to the system in the hospital. But we also have our app and web viewer through which people can get notifications, and people can also very nicely collaborate. That's in a nutshell what we do. We have a suite of algorithms. I won't go into detail about them, but for example, we have hemorrhage detection. That's the brain bleed. And if you want to treat a stroke patient, if a stroke patient has a blood clot, for example, you might give them some blood thinners to eat away at that clot. But if it's actually a brain bleed, please don't do it, because then you make it way worse, right? So that's like the first step in stroke treatment. Is it a brain bleed, or is it maybe a blood clot, which is the LVO detection that we have here? And I'll save you the details of the other ones. We have a suite of algorithms that we run. Okay, that's in a nutshell what Nicolab does. So what problem did we run into? Okay, so we're operating in the medical space, and medical certification is very strict for good reasons. So it's very important that we test our product. We still want to, we're in the software space, so we want to iterate fast, we want to develop, but we don't want to, we don't want to have any severe regression, right? That's not cool. Okay, so imagine I'm updating some component in our system. I'm a happy developer, that's very nice, I've made my change. And now I've also written unit tests, by the way, but I don't really know how my component plays nicely with all the other components we have. Okay, so I want to do like an integration test, right? So we might have a test environment for this. So I'm updating my Terraform config. Okay, I've got this new component, new version. Awesome. And I apply it. And then we spin up in the cloud our testing environment. That should mimic production, right? Okay, then I can sometimes manually always run my test, check if everything still plays nicely. And if it's green, okay, nice, I can go pick up my next task from Jira, and the cycle starts again. But if it's red, and my tests fail in some reason, the cycle also continues, but in this way. I might have to go back to my component, and you can see that this development cycle is already a little bit painful, right? Okay, they can be painful. Cost of running them can be high, both in development time, but also in spinning up this test environment in the cloud. And we're running it as a separate process. So I've updated my component, my unit tests are green, but then I get into like the next development phase. Okay, so this is a testing pyramid. There are different versions out there, but it boils down to the same. So your unit test, you test your individual components, your method, your function, your class. And then you get integration tests, and end-to-end tests in our case would, for example, be we upload a scan, and we look at if our mobile app receives a notification. So we run through the whole thing. We'll focus on the integration test, and I reckon test container sort of sits in between. We run it as a unit test, but it offers us integration test capabilities, to a degree. So what are they? It really boils down to, it's an open source library, and you can easily spin up Docker containers that represent your external dependencies. Started in 2015 by Richard North. He started for Java. We're currently, I think, 10 or even more languages are supported, but we'll focus on the Python part. There's also a company that tries to monetize this, but we'll focus on the open source component. It's the one we've been using in Nicolab, and it works fine. So you can just pip install test containers, you get it, you can start using it, and a lot of services are already supported out of the box. What can we see here, for example? Oh, wrong button. Kafka, Weaviate might be interesting to some of the crowd here. Whole bunch. Or you can build your own if you feel like it. If you have your own service that you want to test against, that's obviously not a community module, you can wrap it in a test container. Does anybody know who this dude is? One hand, nice. More. It's Ryuk. He's from some manga called Death Note, and he's kind of like, see it as the god of death. And test containers named a container that they spin up for you after him, and it's really Docker garbage collection. So if I'm running a test container for my test, it's going to spin up a Docker container, but my test might fail, and then I get all these Docker dangling resources, right? Ryuk will solve this for you. There's a bit of a delay, and then Ryuk looks at, oh, this all belongs to my testing session. It looks like, excuse me, test is finished. I'll kill off all the resources. So that's networks as well, running containers, and I think mounts, not sure. Okay, so we can manage our external dependencies. I kind of like to think of it as an integration test light, and we run it from within our Python tests. Let's look at a little demo. If anyone has ever suffered from imposter syndrome, this is way worse if you put on a lab coat for something that you should study 10 years for. I got away with it. I hope this is readable. It looks okay. So I've written a very nice little class called myCache, which is really just a wrapper around Redis. And we have a write method where we put a key value store, and we actually just set it to Redis directly, and we can get something with a key. Super simple, but it'll serve illustration purposes. So in a classical case, we have this external dependency, Redis. What one might do is mock this away. So I've got a test here, I've got a key, PyData, I love you. But in this case, we don't have the context of Redis running, right? So we introduce a mock. A mock is an object in testing that you can manipulate and that can replace something else, and you can say, I want you to return ABC, or you can play around with it. So here we say, if get is called on this object, the return value is the value, is love you. Okay, we put that as our Redis client, we write a key value to it, and we assert it. Let's test this. Oh, I want to say it's green, it's actually yellow, but it passes. But we're not really testing anything here, right? We just set the value, you always return this, yeah, then of course this assert is going to be true. It's a bit of a contrived example, but it'll show some of the shortcomings of mocking. So something else that we could do, it's basically the same example, but now I put a different key here. I love Java. That should not pass, right? Oh, yet it does, because we've set this mocking here. We can even comment out writing to this thing, and it'll still pass. So, case in point, you have to be careful with what you mock, if your test is still meaningful. In this case, it totally isn't. Okay. I've got a different example here. I've got a super simple function, multiply, a times b. Super interesting. And then here I introduce a fixture. Sorry for the thing that pops up. And a fixture is a PyTest specific thing, which in this case is a function. And if I then have a test function, I can give that name of that fixture, and then PyTest will infer what is the return value of this thing and basically plug it in. In this case, it's not super handy, but if you have extensive tests, this is great. So this returns to 5, the tuple. We put it in here. So on this line, A will be 2 and B will be 5. So we get a result, and that should be 10. Yeah, okay, cool. The nice thing, though, is from fixtures is that you can yield results. So then when you execute your test and you get to this line, this result is returned, but then execution is stopped here. So I'm doing some print statements here. Oh, sorry. So before test is where you would do your setup. Then you would return your fixture that you want to use in your actual test. And then you can do some cleanup. And that's a pattern we will see that we use in test containers. All right, we plug it in here. Let's uncomment the asserting part. And then you will see run before test, then we assert, and then we go back to the fixture. Now, most people will be familiar with this, but I thought I'll explain it anyway. And we will use this when we actually get to test containers. Okay, so I've got a Redis container, I'll start it. And the nice thing here is, on this line, is the test container already gives us a method to get an actual Redis client that we can use. So there are some convenience methods, and every container will expose their own, so you have to look into it, what you need. And we can plug this in directly here. In my cache, we assert like we did before, and then we stop the container. Let's see if this works. Oh, that's slow. Yeah, it passes, but it takes 4 seconds. That's a little bit suboptimal. Let's see what happened here. Okay, we instantiate, blah, blah, blah. Okay, first it pulls that reuk, that garbage collection thing. It does that for us. It waits for it to be ready. So after some time, the container signals, yeah, I'm ready. Then it'll pull Redis. It'll start it. And then there's some waiting for the container to be in a healthy state. Right? If you spin up a container and you start testing against it immediately, Redis might not even be ready for a connection. And then your test will fail. You don't want any race conditions there. So it pulls 4 times here, and then eventually it'll be ready, and then it'll execute the test. But we already see here quite a bit of overhead, right? 4 seconds. I think I connected to my mobile, so there might be additional delay there, but it's definitely significant. So we can also improve our test a little bit by introducing that fixture that I talked about. Then we have a Redis container here, a context. We do the with statement here, so the start and stop container is managed for us, which is nice. We just yield the test container, plug it in here, and this will become our test, and we do the same assert. I'll show you that this actually works. There's the assert. Yeah, it's a little bit faster now. Okay, nice. One other thing I want to show you is where this overhead of starting up these containers can start to bite you in the bum. So here I run the same test as before, but I do it 100 times, just with a different value. Let's see what happens. And we're going to run this sequentially. All right, I won't bore you with the 100, but it's doing the same thing, right? Pulling, stopping, running this is painful. So 14 passed in 12 seconds. This is because we are using scope function here in this fixture. So every function call, every test function call will get a new execution of this Redis client. So behind the scenes, we'll get a new container. So what we could do is set this to session, for example, to our testing session. Then we'll still have the initial setup, but we'll only do it once, and then we'll reuse the container. You can do this, and in this case, it's fine, because we're just running sequential set get calls to Redis. But you have to be mindful that at some point, if you have very complex state, if you have Postgres, for example, and you want to do some initial setup, that there might be conflicts here. Well, that's a super simple demo, but it'll show you the basics of test containers. So how do we actually use them? So the first case is we have one of these algorithms that we were running. Okay, that's nice. That's done. It'll produce results, nice color maps of the brain, that kind of stuff. And we'll feed that to some sort of a postal service. And the postal service's job is to send these results out into the world. initially we had this set up, and we were fully embedded in the Google ecosystem. So the postal service would trigger some cloud task for some post-processing. It would send some messages on PubSub that, for example, a notification on your app could respond to or listen to and then activate on, and the results would go to storage. That was our initial version of the service. And then we realized some clients, they didn't love that we were embedded in Google, and they had different cloud requirements. For example, we want you to be on AWS. Well, then this doesn't work, right? So we were looking for open source components to replace these with. We found them. We wrote our own little server. That's the HTTP part. Nets replaced PubSub and MinIO cloud storage. And the nice thing now is, if you've set up your code in such a way that you can do nice dependency injection there, adding additional tests for these is very easy. Because if I'm a developer and I'm responsible for making this change, I can already test this to 99% before having to involve DevOps and say, oh, hey guys, actually in a test environment, I also need nuts now and MinIO. I can already do this myself, which is very nice. Hello? But we also wrote those same unit tests for this in the same manner. And here comes a problem, is I can't get a Docker container for Google Cloud Storage, right? That would be quite cool, actually, if you could. So what did I do? I used a storage emulator that somebody wrote, OITA. Very nice, thank you. But this kind of replaces the problem, right? I'll show you actually what it is. This is a work in progress and only supports a limited subset of the storage API. So what did I do now? Okay, I'm kind of mocking again, but now I'm mocking in a container that I'm spinning up with test containers, but I still kind of have the same problem. I don't see a way around this. We did stick with this just because we then have a nice clean interface in our test, that we do everything with the test containers and not mock parts of it and other parts we didn't. But if you can't find even an emulator, yeah, then you're out of luck. Something else that test containers will do is that because you're doing an integration test, you might want to test the state of your components, right? If I write something to storage, I want to then assert that what I think I've written to storage is actually in there. So your assertions can become more complex. This is a very simple example, is, oh, I expect a certain set of blob names. Here's my storage bucket, which will then point to your test container, and then make sure that both are the same. What we also did is we have some components that we use a lot, that different services use, and we've written a few wrappers around test container, which is a wrapper around Docker. Nice. And we use it both in Go and in Python, and the one that we've put the most work in is nuts. We call it TC nuts here. And basically what we do is you might want to do a lot of complex setup. If you have a Docker container, you have nuts, but you have nothing, right? You don't have a topic or a stream, whatever you want to call it, or consumers, subscribers. And we've written a wrapper around it that you can feed it a config file that can live in your test or somewhere else. And then you spin up our version of test container nuts, and it'll do the whole initiation of your service. So you could do this kind of stuff as well for Postgres if you want to have test against certain tables. Just create them already, and you're good to go. Consumer is the same. I won't bore you with that. Okay. So let's go over some of the advantages and disadvantages. I said they can be painful to run. Did we solve this? Well, some cloud services are hard to represent. So there, I'd say maybe partly, not really. But the other ones, yes. Something I haven't mentioned yet is that you have to make sure if you have a production version of MinIO or whatever service you use, that you probably also want to test against that one, right? So you want to keep them in sync. There's a bit of additional admin overhead. We said before, cost of running integrations can be high. I would argue test containers sit between unit tests and full integration tests. I think in terms of money, they're definitely cheaper. They can be a little bit harder to write from a dev perspective. And we were running an integration test kind of as a separate process. Well, that we have definitely solved. The only thing is if you want to include this in your CI/CD, we had issues with setting up Docker in our GitLab runners, which were running on Kubernetes. There's some security issues there, but if you solve this, then it just becomes part of your unit test suite, which I think is the biggest advantage of using them. So, to kind of summarize, I love them for black box testing. So at the highest level, I have the service, I put something in, something needs to happen. I love that they're contained in my repo. So if you get a new developer on board, there's a lot of documentation, right, that a test like this tells you. And they can start developing more easily instead of having to onboard them on the integration testing part of things. And they're very easy to run. I start to dislike them a little bit when I have complex state. But I think this is, even if you wouldn't use test containers, having complex state to test against in your integration test is, wouldn't call it a code smell, but is an issue that you will have regardless. They can introduce some overhead. I have not really experienced this yet. I also don't run the same thing 100 times like I did before. And debugging can become a little bit harder because you might have to debug the state in your container, which might not always be easy to navigate. And the container gets shut down afterwards, right? We had these nice context managers. So I have a pro tip for you. If you're debugging your container, just put a time.sleep in there so it doesn't get shut down. Just don't forget to remove it, because I was wondering why my unit tests were so slow. This actually happened. I did it so you don't have to. So I would definitely use them again. They're kind of part of our standard arsenal right now. Just be mindful of the state and the overhead. Use them especially for black box testing, but they don't fully replace your integration test, right? Because you're still bound to your local way you set up the containers. Might not 100% reflect your production state or your test state. So I would still do those, but hopefully that feedback loop that I showed you would be more green, quicker. That's it. If there's questions, hit me up. I shared the link to the repo that I showed you with those super simple test cases. We are looking for a Golang Python developer. If you're interested, talk to me or to Attila here at the front. I'm happy to answer any questions, and I really need a sip of water. Excuse me.
Questions?
Thanks for a very interesting talk. We use test containers ourselves and also find them very useful, but what I'm personally sometimes struggling with is indeed managing the initial state of this container, or rather seeding it with data if we're talking about databases.
Yeah.
Do you know of any best practices here? So specifically, right, do you create Python objects and then seed them into the containers, or do you use CSV files and kind of mount them to the containers? Or you also showed the config example, right?
Yeah.
What are recommendations?
Good question. So if you have multiple services that start to use the same dependency that you want to use in a test container, then you can definitely start to think about what we did with what we did here to make this easier. We realized NOTS is such an integral part of our infrastructure that all these services, they get triggered by an event and they send out an event, and so that made a lot of sense for us. I don't think we've found the perfect balance here yet. So some repo, this postal service that I showed you was the first one I introduced it to, so then everything stayed local. It's still local there. Maybe some parts could be promoted to here, for example. Yeah, it's a bit of a balancing act. I haven't found the golden path yet. Yeah.
Thanks.
Thanks for the talk. In line with this comment about how to test databases, we don't use test containers ourselves, but what we have done is within the test itself, we define using f strings what the data looks like. So let's say we want to test an aggregation. We know the result of this aggregation, so we provide the columns we need with data we can control and we can easily read in a test. Then if you want to spin up a container with, let's say, a MariaDB, what you make is you use the hook. They have to load a script as inserted as a database. It's not a perfect solution. You still don't have protection data, but you can test your aggregation in this case, and you are doing that locally using a Docker container. So maybe with test containers can be the same if you can tell them, okay, when you spin up, take up this MariaDB SQL script or similar for the databases and just load it.
Yeah. Okay. I didn't fully. Was there a question in there?
No, there was no question. It was a note on the previous question and in line with your talk.
Okay.
So how to ingest the data within the container so you can run your test. It's not just attuned to your presentation or an addition.
Yeah. Cool.
Yeah, I see a question here.
Yeah, thank you. The goal, or maybe not the total goal, was to sort of replace integration tests, and you said not really, right?
Yeah.
And well, we did a lot of those, and we realized even that we couldn't really use fake data to really do a good integration test in the end. So to do a full sort of acceptance test before production, we actually just use production data in a sense, right?
Yeah.
So this test setup, I mean, it will always involve sort of mocked data in the sense that it cannot be fully realistic, although it mimics the production environment, right?
Yeah, so there are two things there, right? You can mock the data that goes in, or you can use production data. For example, what we would do, we have a set of kind of standard scans, brain scans that we have, that we feed into our end-to-end test. And then we know what, this brain scan has a thrombus, has a blood clot, we know where it is. So,
but is that not too private to just dump into a local machine? Or?
Oh, sorry, this part is more the end-to-end test that I'm talking about.
Yeah.
But what you're saying is if you use production data, if you need that to accurately describe your state, then mocking your production data is going to be maybe a problem. But the integration I'm talking about mostly here is if the components play nicely together.
Yeah, and on that part, just secondary question. You pull in a lot of code, that is not used on production in the sense that versions might be different, APIs might be partial, but all these containers don't live in production. Yeah. You pull in so much code that I wonder, in your experience, how stable is this and how representative is this for later stages? I mean,
A good question. So I can't think right now of a situation where the version or the state we set up in our test containers clashed with something we had in our actual integration test. So I have not experienced a mismatch there. I can imagine that they'll pop up at some point. So for us it's been very stable, and it has definitely sped up that feedback loop, right? Because I'm not going to put something in the actual integration test if my own integration test light fails. So you capture a lot there already, but you can't capture 100%.
All right, thank you.
I think we have time for just one question.
Yeah, actually a follow-up on the previous question. I think it touched a bit on the versions. When you set up a test container, do you have like the same possibility of choosing versions as for the real versions of the applications that you're using?
Yeah, I can show you. So here we have the Redis container, and this is its signature to instantiate one, you basically give it an image. Here we do Redis latest, so I just took all the defaults, but you can go whatever you like here.
It's a Docker image, so yeah, if it's on Docker, you have it. Okay.
You can also play around with the port and the password here, for example, and that password then gets nicely fed into that Redis client that you get back. I can show you later if you want.
Thank you.
Thank you, Barend. I think with that, we need to conclude our Q&A. Thank you also for those who were asking questions and showed a lot of interest. I think Barend needs another round of applause for also the live demo at his first PyData.
Thank you. I have to say it was very nice to do this, and I've been in the crowd plenty of years. I'd like to invite you all, if you think of, oh, there's this nice tool that I use in my work, or just put in an abstract and see if it gets picked. I can recommend it.